I'm Stephen Foskett,
I'm Chris Grundemann.
and this is the Utilizing AI podcast. Welcome to another episode of Utilizing AI, the podcast about enterprise applications for machine learning, deep learning, data science, and other artificial intelligence topics. Each episode, we've asked many different questions, from the specifics of technology to implementation details to talking to people who just got us thinking. And that's what's happening this week. Effectively, one of the things that it's just always in my mind is, why are we using AI or ML or deep learning or this specific technology for this specific approach? And we don't always know exactly why that was chosen. And Chris, I mean, sometimes it doesn't fit, right?
That's absolutely right. And I think this plays a little bit to the issue of how big AI really is and how many different algorithms and different models all fall under the idea of artificial intelligence. And a lot of people want to talk about very specific things when they say AI, even though it's a general term. And I think deep learning is one of those very specific models and algorithms that we're using currently. And sometimes the answer is we use the hammer we have, and sometimes we're using the actual correct tool. And so I think that's probably what we'll dive into here, and understanding that there are other tools available and when tools are most valuable.
So back in November, there was a question. Eric Lincoln posted a question in a sentence: what is AI good at? And Rich Harang responded, well, hello there. I have some opinions. And boy, did he. Rich's thread was great. And the whole topic of the thread was, why the hell are we even using deep learning for this particular application? And yet, it wasn't just a rant. It was actually a very smart summary of a lot of the questions that we've had. So that's why I'm thrilled to introduce Rich Harang as our guest here on Utilizing AI this week.
Hi, yeah, thanks for having me. I'm looking forward to the conversation. So, I'm Rich Harang. I am a senior technical lead at Duo, where I lead a lot of the research into sort of basic algorithmic developments that we use to improve our product. Previously, I did data science and machine learning at Sophos as part of the Sophos AI group. And before that, I worked on the intersection of machine learning, privacy, network security at the US Army Research Laboratory.
So, Rich, in your thread, like I said, it really summed up a lot of the things that I've been thinking about with AI, and a lot of things that Chris and I and Frederick and I have talked with our guests on this show. But it really all comes down to the whole question of, when all you have is a hammer, everything looks like a nail. And right now, everybody's favorite hammer is machine learning, or deep learning specifically. And it seems like everybody's trying to do everything with deep learning. Is that how it looks to you?
I think that I think it's overused. I think it's used more often than it should be. But I also think that there's a certain marketing cachet that comes with being able to say, oh, we use like the latest, greatest technology to do the thing. And there's a meme going around at one point where it's got like a dog, and it's like, deep learning, and then like it pitches to the side, it's like machine learning, and then finally, like, behind everything, it's, just a picture of a dog. It says this is just an if statement. So I think like a lot of the time when people talk about, oh, we're using AI or we're using deep learning to do this particular thing, I suspect in practice, a lot of the grunt work is still being done by simpler, more robust techniques on the back end. But it's certainly talked about way too much, I think, or out of proportion to how useful it actually is for a lot of problems.
So when you say that we're kind of over marketing or over hyping deep learning, maybe at the expense of talking about some of the more practical and hard-working algorithms that are actually doing a lot of the work behind the scenes, what are those other types of artificial intelligence, or are they even types of artificial intelligence that is out there doing the grunt work?
Oh, artificial intelligence is not a term that I think is really well defined in a lot of cases. The stuff that most often gets used, like if you wanted to pick sort of the data science technique that gets the most traction, that gets the biggest bang for your buck, it's going to be like an SQL query, right? SQL queries and Excel spreadsheets drive business. And so if you want to stretch to the point where you're saying, oh yeah, sure, maybe that's a kind of AI, You can say, yeah, we use AI all over the place. Once you get past things like SQL statements or SQL queries and Excel spreadsheets, even just simple linear models carry a lot of weight. I think the next step up from that is probably like random forests. And so by the time you get through that all the way up to like these deep learning, 10 million parameter models, I think you're sort of looking at a very small part of the solution space that's left, at least that actually requires them, as opposed to where they get kind of shoehorned in because it's easy and it seems easy and it seems fun and it seems like, oh, why wouldn't we use the most powerful tool available, as opposed to like what can we actually do to generate value and avoid cost.
So we're essentially talking about AI washing here to some degree, right? Where we're using common data science tools that have been in use for a long time. Maybe we have more data or better data than we had in the past. Maybe we don't. But then we're coming out client facing and talking about deep learning and neural networks and machine learning because that's what the audience expects us to hear, or is there some other fundamental reason that that's kind of being used as or being touted as the power of the machine?
Yeah, I think it is to a certain extent AI washing, right? And if you want to say, hey, these are the, like, nobody ever wants to be like, oh, we solved this problem with the 20-year-old technology and it does great, right? Nobody gets excited about that. When maybe they should, because you can use the 20-year-old technology. It'll cost you, 10% the maintenance burden and get you 85% of the effectiveness. Numbers completely made up, but, in that ballpark. But there's no like there's not a great press packet you can put together through that, right? Like no one's going to get excited for like, we had this problem and we solved it with linear regression, right? Whereas if you can turn around and say, oh, like our next gen super duper, self-evolving, non-deterministic quantum, pick your buzzword, AI, right? This is what we're using to do the thing. And then everyone's like, oh, well, it must be good.
In your thread, you posed a huge number of requirements for AI. And I think that was pretty smart because essentially what you were saying was we need to figure out what problem set is best served by AI and deep learning. And some of those things, I think, are things that people can immediately grasp. For example, the decision needs to be something that is expensive for a human to double check, but possible for them to double check, like, select all the buses, there needs to be a lot of the same kind of decision, as you said, zucchini versus volleyball. That's not just something you're going to be doing all that often. And there needs to be some benefit from making the right decision. I think that these are some of the questions maybe that people have. And so when you're looking at things that we've talked about here on the podcast, like, for example, intrusion detection, you're making a lot of the same decisions repeatedly. There's a huge benefit to getting it right. A human can go back and check those things and say yes or no. So it's a very good application of machine learning. But of course, there are lots of them that kind of aren't great, applications of machine learning, and those tend to wash out, right? What do you want to say? I guess first of all, let's talk about decisions. What is deep learning really good for?
So I don't want to like undersell deep learning in general, right? Deep learning is really good at taking huge amounts of data and essentially learning extremely complicated, and usually, often, there's some caveats and some wiggles we can get into around it. Usually, like very high performant rules and sort of classification strategies. The two questions are: what do you have to pay to get that? Because training models, the care and feeding of deep learning models can be horrendously expensive. And then, is it worth the effort? Right? If you don't actually need, the 4 nines of performance that you can squeeze out of a very highly tuned, carefully researched, super large, deep learning transformer based whatever. If you don't really need the 5 nines and you can get by with like 95% accuracy, you can use the deep learning model and it may solve the problem you need it to solve, but you're using way bigger guns than you actually need for the problem, right? And again, you can get by with something that'll get you 85% of the way there at 10% of the cost.
Mm-hmm.
And so that's for me what I see as the biggest disconnect, really. It's like, yeah, deep learning techniques, they really are like fantastic general purpose problem solving techniques. But you have these issues that come up with interpretability. You have these issues that come up with like sort of learning weird patterns and extracting strange biases from the data and not really being able to diagnose them. You have, again, just the tremendous cost of care and feeding and retraining them. And then also these deep learning models tend to be large and somewhat expensive to run, especially compared to much simpler models like linear regression. And so that actually limits the places that you can deploy this, right? If you want to deploy it to a mobile device, a deep learning model often can be challenging to do, whereas again, like a simple linear regression or a logistic regression or even a smallish random forest tend to be much more compact and much faster.
And I see this a lot with IoT and devices like that too. Where I mean, nowadays we've got everything has to have person detection, all that kind of stuff. A motion detector can be implemented with a few discrete electronic components. Do we really need a deep learning model to identify that that's a human when the little red thing in the corner like triggers the thing just whenever there's motion? There's a lot of use cases like that I think that people are maybe going a little overboard with deep learning. And then of course you mentioned rules, which is another thing that always gets me. In many cases, an expert can come up with some pretty good rules that we can use. I mean, we've been doing this in firewalls and so on for a long, long time. Do we really need an opaque black box machine learning system to decide if an expert could have just thought about it for a month and come up with a bunch of rules that could trip, basically be more predictable, more understandable? Of course, there are benefits to it, but these are the questions I think that we need to be asking. Like, what kind of problem set are we dealing with, right?
Right. And I think, like, I guess, like, the thread I do come off as highly critical of deep learning and, sort of these black box methods. I think there is a place for them, right? There's
Oh, absolutely.
definitely places where there's almost nothing else that fits the bill, right? If you're doing like facial recognition, I don't like people spend a lot of time with like hog features and sift features to try and get facial recognition working. It wasn't until we got these deep learning methods that we really started to get like the super high levels of performance that we see today. And most of like the really successful cases I can think of for deep learning land in sort of that image-ish kind of space. You can find other places where it works really, really well, but the number of places where you could get away with something that's simpler and cheaper and easier and more interpretable is, I think, a lot higher than at least sort of the tech press would would have you believe, right? A lot of the time, and I think a lot of the time, like within business, people realize that, right? When people start to look at like the cost of spinning up, a full deep learning stack and very often they sort of look at it and they blanch a little bit and they're like, so how about those SQL queries, right? And then even like beyond that, right? There's a lot of times where not necessarily with deep learning, but you can use a combination of sort of like data driven approaches and writing rules, right? That's a lot of I think that's a very underutilized set of techniques. Is you spend a lot of time, dredging through the data using different, sort of machine learning or um, statistical techniques to analyze the data, and at the end of it, you distill it down, maybe in consultation with a subject matter expert or using your own domain knowledge, you distill it down into a couple of rules. And then what you deploy, quote unquote, is a bunch of if statements written in code. And everybody knows exactly what's going on with all of it, right? You can, whenever it hits a decision, you know why it made that decision. And if you end up with a wrong decision, then you can start looking at when you maybe need like special cases or exemptions or what sort of edge cases it's failing on. And all of it is eminently debuggable and eminently understandable. And in a lot of cases where you're dealing with compliance issues, right? I don't remember if I touched on that in the thread or not, but you've got this whole space of like regulatory and compliance issues in regulated industries where if you use a deep learning model, you could be in real trouble because it comes back and says, hey, like, you appear to have some sort of like bias against this group, or you need to prove to me that you aren't making these selections in a biased manner. And if you have a deep learning model, you're kind of out of luck at that point. There's not a lot of great interpretability stuff that goes on in that space. Whereas if you've distilled all this data down to, a chain of 15 if statements, then you're like, okay, well, here's exactly what's going on.
Yeah, here's the decision tree. Yeah, you did say you have to not care how that much about how the answer got, how you got to the answer, right. Only that, you got an answer.
Yeah, well, and this reminds me a lot of, just working in IT in general, right? And so maybe to kind of zoom out of the problem space a little bit, I've definitely had lots of times where, somebody came to me and said, oh, we've got a BGP issue. And really it was their Wi-Fi on their laptop was turned off, right? Or somebody coming and saying, hey, the server's down, and really they've just, they don't have the application on their laptop, and all these excuses. And what I mean is it's a little bit of this area of the tail wagging the dog. And so I think anytime you're approaching a problem space in the technology world, but probably outside of technology as well, it's really good to understand, what are the problems we're actually trying to solve? What are the requirements? What are the constraints? And then let's go out and solve that problem. Versus, I think what I hear Rich saying is there's a lot of cases where folks are kind of backing into this saying, oh, we need to find a way to go deploy deep learning. Let's try and find problems to attack with the solution. In a lot of cases, right? This is a new hot thing. We need to find ways to use this versus, hey, we have these problems. Let's figure out how to solve them. And I definitely see a lot of that in a lot of different areas of IT. And this just seems like one more area where we should be very careful to approach problems with the right tools versus approaching our business with tools and trying to find problems.
Yeah, and that being said, of course, we can take this entire discussion and flip it on its head and to say, how do we identify places that we should be applying deep learning? And all of these things are really great reasons to apply deep learning. So, for example, as you mentioned there, if we have a problem set that does have lots of yes/no questions where it's kind of an even balance between yeses and nos, where it's a similar decision happening again and again, where we've got a lot of training data, where we don't really care how we defined it. We just need to decide whether we're going to open or close, things like that. I think that those are great applications for deep learning. And those are the kind of things that we should really be looking for, right?
Mm-hmm. Yeah. And I think like I had that whole list of like different things that make a problem a good fit for deep learning. I think I want to emphasize it's not like if you don't have all of these things, you just give up and not use deep learning. I think that the more of those attributes you have, the more likely you are to see success with deep learning, right? So, when we were at Sophos, right, we were looking at like malicious URLs, we were looking at like malware, right, detecting malware with deep learning. And in that case, the base rate is unbelievably skewed. We're nowhere near even odds. But you can still use deep learning really, really successfully there, which, Sophos has a great anti-malware product, which deep learning is a significant part of. I'm only slightly biased because I spent a lot of time working on it, but I think it's a place like that, right? There's tons of decisions. You need to look at lots of files, right? It's hugely imbalanced. And that gives you an incredible headache when it comes to saying, okay, how well is this actually working? But it may be the case that the value you get from that model is worth that headache. And I think that's, if I had to boil it, that whole thread down to one thing, I think it would be kind of what Chris was saying. Use the tool that's right for the job, and just be aware that deep learning is sort of like a specialized, expensive precision tool. It's not really universally, I mean, it's a weird case because you can say, it's universally applicable, right? It's this class of like universal function fitters and, theoretical results that like, yeah, I can learn any kind of function that has these properties and blah, blah, blah. Yes. Okay, fine. In that sense, it is like the universal tool, but is it really like cost effective? Are you going to like save yourself money by jumping right to deep learning, or should you sort of start small and work your way up until you finally decide like, yeah, I absolutely have to get that last bit of tail error squashed, and I know that if I do that, I'm going to come out ahead in the game, right? And yeah, I've thought about the costs of like implementing it, and the costs of like retraining the model, and the cost of like curating the data and getting this huge volume of data like brought in and analyzed and labeled and so on. And at the end of all of that, I can, even with all of that, it is still worth it to me to pay for all of that to get this last, like, squeeze these last little bits of precision out of the model. Then by all means, you should be using deep learning. But like Chris said, I think in a lot of cases, it's someone comes up with a cool model and they're like, okay, crap, how can we monetize this? Or they're just trying to get kind of on the hype train and say, hey, we use AI, right? We're an AI driven startup, right? And the question is, okay, do you need deep learning to solve this really hard problem in a way that nobody else can solve it, and this is the only way to do it, and now you have sort of like this edge over everyone because you've built this technical moat that's only solvable by deep learning, and nobody else wants to get into it? Or are you using a shiny object because you've got research scientists on staff who want to use shiny objects and play with the cool new toys?
Yeah, and I think that goes all the way back to some of the things you were saying in the very beginning, Rich, which is that this isn't just what type of artificial intelligence is best for this use case, but that there's some really solid data science that works in a lot of cases, and you don't even need to go to artificial intelligence, right? I mean, and you mentioned SQL queries and Excel spreadsheets, and I think that to your point, right, that they are the unsung heroes of data science, and there's a lot of things you can do with data that doesn't involve any kind of artificial intelligence whatsoever. Is that right?
Yep. Yeah, 100%. And it shouldn't be the first thing you reach for. It should probably be close to the last thing you reach for. It's when all else fails, and I'm still convinced that I need it and I can extract value from it, then okay, well, let's think about jumping into the deep learning pool. But yeah, again, like the most, I don't know if I can say what it is, but the most impactful model I've ever written, and I put model in scare quotes there, was about a half dozen if statements and then a summation. And that didn't come from like burning my own personal, chunk of the rainforest down in GPU hours. That came from a lot of Jupyter notebooks and pouring through data and talking to subject matter experts and trying to like fudge together something that made sense. And then we made something that made sense and we deployed it and it worked great.
And it's amazing what you can do with a few kind of if-then statements in a row. I mean, basically, it's the old expert system, right? If you can divide up the problem set and then divide it again and divide it again and divide it again, in just a few questions, you can get pretty far in many cases without having to have this black box trained to basically find that answer for you. But at the same time, there are many areas where you can't do that. And I think that that's the important thing. One more thing that occurs to me, though, is that some of the answers to these questions are going to change over time. So one of the challenges that you present is this sort of kind of fitness to purpose in terms of, is the model too big for the problem? Are we using a sledgehammer to put a tack in the wall, right? Well, what if technology changes and suddenly we've got lighter sledgehammers? What if we've got, the ability to do this on mobile devices or IoT in a way that we don't maybe now? that could change the equation quite a lot, couldn't it?
Oh, for sure. And there's cool stuff coming out in different kinds of hardware accelerators for doing deep learning or deep learning like tasks. And if any of those, so the faster those develop, the more developed and the cheaper those get, and the lower they bring the costs of deploying these things, and the more ubiquitous this kind of hardware becomes, then I think the lower the bar gets for like how hard does the problem have to be, how much value do you have to extract from it to be able to use it. What it does not solve is the back end, right? The data. How do I get the data? How do I get the labels? How do I get this curated and cleaned and into my system for training? That is not a hardware problem. That's in a lot of ways it's a domain expertise problem, and it's a lot of engineering problems. And so that is not something that a lighter sledgehammer will necessarily solve. But on the hardware front, for deploying it, absolutely right. The better the hardware gets, the easier it becomes to make the case for using it, because hey, I can get this really powerful model for which I can deploy everywhere. Right now my fridge can do facial recognition, if that's a thing that you think it's really good for your fridge to be able to do. But then I think there's also, I don't know how strongly I believe what I'm about to say. It kind of like waxes and wanes depending on the day. I think there also is a case to be made that the hardware that we're using is actually in some ways giving us tunnel vision with respect to what we do in the space of what kinds of models we fit, what kind of machine learning we use. There's a paper called The Hardware Lottery, who, it escapes me at the moment. I deeply apologize to the authors. I'm blanking on the names of the people that wrote this paper, but that essentially is the argument they make, that hey, we've got these GPUs, right? And it's not a huge surprise that deep learning and backpropagation and all this stuff started taking off at about the time GPUs became commodity accessible, and the sort of the infrastructure to do these GPU based computations became widely available. Suddenly this became an easy way to build really big models, and a lot of other trains of thought kind of fell by the wayside, and suddenly it was just everything is backprop driven models. And so in some ways, are we sort of victims of our own success here, right? We've got the hardware that gives us the cool models inspire us to build better hardwares, and we're just sort of like spinning around this very, or dare I say it, a local optima perhaps, of backprop models that get trained through backpropagation and play nicely with like sort of these simple parallel computations you can do on a GPU. So in some ways, I think if we had hardware that worked really well with different classes of models, that might sort of open stuff up to new and interesting techniques within the machine learning research space.
I think that you're referring to Sarah Hooker's paper, likely, and but what I was going to say is that such is the nature of the history of technology as well, in that the tail does tend to wag the dog, and if we have tools of one sort or another, we tend to continue to go in that direction. I mean, I think that's why, for example, we're continuing to use internal combustion engines everywhere. It's just because that technology has matured to such an extent over 100 years that even though it's not the right technology for many, if not most, problem sets in transportation, we're still using them because it's well proven. And I think that we may end up going in that direction with this technology as well.
Well, it's not just that, it's also the entire infrastructure that gets built around it, right? Because once you've got internal combustion, once you've got to you've got roads that work great with cars that run on internal combustion. There's built to withstand the speed range that internal combustion engines travel over, and you've got gas stations and you've got gas pipelines, and all of this gets built up. and it makes it's almost sort of like a lock-in, a technology lock-in, right? Because to move to something like electric vehicles, right, you've got to build this whole parallel infrastructure of like charging stations when we've got all these gas, stations already. So I think the analogy does kind of hold, because if we focus on these backprop, GPU driven models, then we deploy we build stuff that runs them, and then suddenly these are the devices that any model you want to deploy has to run on, and so it biases you towards that kind of model, and so on.
Well, thank you so much for this great discussion. It's been a lot of fun, but the time has come now for us to move on to the next section of our podcast, as we traditionally do. We're going to ask our guests 3 questions. As a warning, Rich has not been prepared for these questions, so we're going to get his off-the-cuff answers right here and right now. We're also going to change things up again here in season 3 by having a question from a previous guest asked of Rich as well. So, Chris, why don't you take the first of the 3 questions?
Sure. Thanks, Stephen. So, Rich, we've talked a lot about, some of the things that maybe machine learning and deep learning and artificial intelligence in general won't do or can't do or maybe shouldn't do quite yet. I want to flip that over and ask you, do you see any jobs, any roles that are going to be completely eliminated by artificial intelligence in the next 5 years?
Honestly, I'm going to say no. I can't think. That doesn't mean there isn't one. I just don't have the imagination to come up with it. I can't think of anything that will be completely eliminated. I can think of some things that might change, or will be impacted. Right? You can imagine a world where at some point, facial recognition and image processing and video processing and anomaly detection get good enough that things like, security positions where you've got people watching cameras all day, right? Those will be significantly impacted, and you see a reduction in the number of people required to do that sort of work, because they're sort of enabled and made more efficient by some sort of like machine learning driven technology. I periodically hear, maybe this is just like the weird corner of Twitter that I'm dragged into, but you periodically hear things like legal discovery and paralegals are going to have their lives sort of upended by machine learning technologies. But at the end of the day, especially within 5 years, I cannot imagine a world where machine learning or AI or whatever you want to call it gets good enough that you can completely take humans out of the picture. You can you can come up with stories where like sometimes humans end up in more like supervisory roles, where they're sort of like double checking what the machine learning does and keeping an eye on it to make sure it doesn't go off the rails. But if for nothing else other than just like purely compliance reasons, right, you got to have someone to blame if something goes wrong. I have a hard time seeing a class of jobs just being just completely wiped out.
Well, thanks for that, Rich. That's one of our classic questions. Another classic question I'm going to throw to you, since we did talk about this a little bit during the episode. How small can ML get, or deep learning? Will we have household appliances running this stuff? How about toys? How about disposable devices running deep learning?
It depends on what exactly you want to put around, or what sort of box you want to put around deep learning. Right now we've got sort of this vague notion that, oh yeah, it's like these like very deep multi-layer perceptrons, and so like that's sort of what a lot of people stick on deep learning. What about just like a single hidden layer? Is that still deep learning, or is that just a perceptron? So I think you can have machine learning. You do have machine learning models that are very small and are already embedded, right? Like you've got face detectors in consumer grade cameras. Getting something like, I don't know, GPT-3 onto a disposable device seems like a long shot to me. I can't imagine a world where that's coming up anytime soon. But if you're willing to sort of think outside the box, going back to the hardware thing, right? If we come up with new and interesting kinds of hardware, there's a company, I'm going to say Light.io, maybe, that's looking at like essentially using optical techniques to get really complicated features, pseudo-random features built out of an input stream using optical techniques. And that gives like an immensely rich feature space than that they slap much more straightforward machine learning models on top of. So you can imagine maybe some sort of hardware-based approach like that gets you something that kind of acts like deep learning in a much smaller footprint. That I could see that conceivably happening. You know, you can keep invoking Moore's law and say, oh, things will just keep getting smaller and smaller and faster. But I think we're kind of topping out on that, and we're faking it by just adding a lot more like hardware to things. The nature of deep learning models is going to make it hard to get them sort of ubiquitously deployed, barring sort of massive improvements in hardware, which could very well come. But all of that, again, comes with a corresponding significant increase in the cost of like fabrication of those chips and research of those chips and stuff like that. So all of which is to say, I'm not super up on saying, oh yeah, we'll get like disposable stuff right around the corner. If I had to put money down, I would say there's going to be like some sort of like different kind of hardware architecture that lends itself more to like different kinds of techniques, and maybe it'll still have sort of like the power of deep learning models, and you can squint and say, yeah, it's kind of deep learning-ish. But yeah, like with our current sort of like hardware paradigm, if that's the right word, IoT devices, sure. Fridges, toasters, sure, if that's a thing that seems like it's exciting to somebody, right? Again, I don't know why you would want facial recognition on your toaster, but sure, maybe you can put it there. But yeah, disposable devices seem like a long way off to me. But that's I'm not a hardware expert by any stretch of the imagination, so take that opinion for exactly what it's worth.
Well, thanks, Rich. And then finally, our final question here. As promised, we're going to use a question from a previous guest. Adam Probst is one of the co-founders of ZenML. Adam, take it away.
Hello, I'm Adam from ZenML, and my question is, how much percentage of companies will be using ML in 5 years?
In 5 years. So if we're going to distinguish machine learning from deep learning, and so anything like starting at linear regression, right, or naive Bayes, or sort of linear models, and going on up counts as machine learning. Within 5 years, I would be surprised if you could find a single company that didn't use some kind of machine learning somewhere in its business in 5 years. I suspect the percentage with sort of this loose definition of machine learning is extremely low even now, right? People are, everything from A/B testing to like things like looking at customer health and customer churn to, recommender systems, right? There's the number of applications for machine learning for like sort of quickly summarizing and analyzing data and making it actionable. It's, huge just areas of application for all of this stuff. So yeah, I mean, making it their primary product or like integrating it directly into whatever it is they're selling, maybe a slightly different question, but using it somewhere within their business operations, it's got to be close to 100%.
Well, thanks very much, Rich. And again, thank you for joining us here on the podcast today. We do look forward to your question for a future guest if you happen to have one. And to our listeners, if you want to be part of the fun, just let us know. Contact us at host@utilizing-ai.com, and we'll record your question for a future guest. So, Rich, thanks for joining us. So where can we connect with you and follow your thoughts on enterprise AI, deep learning, machine learning, data science, other topics?
Well, you can find me. I probably spend most of my time on Twitter. It's just at rharang, RHARANG. And fair warning, I do tend to post a lot of really terrible memes and bad jokes. So if the thoughts about enterprise AI don't attract you, maybe the memes will.
How about you, Chris? What's going on in your life?
Yeah, everything is over at chrisgrundemann.com. You can also follow me or chat with me on Twitter at Chris Grundemann. And LinkedIn is another place to connect and chat about anything IT or AI related.
And as for me, I'm looking forward to our next AI Field Day event, which is going to be coming up here in Q2. So we're going to be having some companies present to folks like us about their products and technologies. We'll ask them questions and discuss and figure out how it works, kick the tires, all on live streaming video. You can find that more information about that at techfieldday.com, or you can find us on YouTube. Just go to YouTube/techfieldday to see videos of our previous AI Field Day event and other topics as well. Well, thank you very much for listening to the Utilizing AI podcast. If you enjoyed this discussion, please do subscribe, rate, and review on just about any podcast application, and please do share this with your friends. The podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to utilizing-ai.com or find us on Twitter at utilizing_AI. Thanks for joining us, and we'll see you next week.